Hello everyone. Once again welcome to PM Networking. Guys, today in this video we will discuss area concept in OSPF, right? How many types of area we have. We will discuss both theory as well as practical. So in this video we will cover everything about OSPF area concept. If you want to learn each and everything about OSPF area concept, please watch this video till the end. I am damn sure you will not have any doubt after watching this video in OSPF area concept. So we have 5 types of area in OSPF. First one is standard area, second one is stub area, third one is totally stub area, and fourth one is NSSA area, and fifth one is totally NSSA area. But question is, why we are using OSPF concept? Why we come up with area concept in OSPF? So guys, area concept is used to filter LSA. Area concept is used to filter LSA. So see, in this topology I have created one topology in GNS3. Let me show you. This is my topology. Here, as you know, by default here in this topology you can see here I am running OSPF area 0. This is my OSPF area 0. This is EIGRP 100. This is EIGRP 200. So router 4 and router 5 is member of area 0 and area 3. So these two router will become ABR, right? These two router will become ABR, and this router number 2 is part of EIGRP domain also and OSPF domain also. So this router will become ASBR, and in the same way router 10 will also become ASBR. Fine. And suppose guys there are 1000 prefix in EIGRP 100 and there are suppose 2000 prefix in OSPF area 0. So router 9 will receive these 2000 prefix by ABR in the form of LSA 3, right? So how many LSA 3 router 9 will receive? Router 9 will receive 4000 number of LSA 3 by router 4 and router 5. 2 number of LSA 3 by router 4 and 2 number of LSA 3 by router 5. Because both router will generate LSA 3 to share inter-area prefixes. So this router will receive 4000 LSA 3, and in the same way this router will receive this 1000 external prefixes by router 4 and router 5, by router 4 and router 5. And who will generate LSA 5? ASBR. ASBR router will generate LSA 5 to share external prefixes. Am I right? ASBR will generate LSA 5 to share external prefixes in OSPF domain. So it will generate 1000 number of LSA 5 to share 1000 prefixes in OSPF domain. So router 9 will receive 1000 LSA 5 also. 1000 LSA 5. And suppose the hardware configuration of router 9 is not much good. This router cannot handle this much number of LSA in their database, or this router cannot handle this much amount of prefixes in their routing table. So you have to filter the database of router 9, or you have to filter the routing table of router 9. You have to reduce the routing table of router 9, right? So for that scenario we have area concept. With the help of area concept we can filter the LSA of router 9, LSA in area 3. Okay, so first of all let me discuss some theory part, then I will come to this topology, then I will configure OSPF. I have already configured OSPF in this network, right? I will perform redistribution on router 10 on router 10 and router 2, so that router 2 and router 10 will generate LSA 5, and with the help of area we will filter some LSA. So first of all understand which area filter which types of LSA. So guys, first types of area is standard area. First type of area is standard area, right? And by default all area are standard area. By default all areas are standard area. Even if you will talk about backbone area or regular area, by default all area are standard area, and in standard area all types of LSA are allowed, right? In a standard area all types of LSA are allowed. Okay, so second type of area we have in OSPF is stub area. Stub area, and this area is used to filter, it is used to filter LSA 4 and LSA 5, right? Stub area is used to filter LSA 4 and LSA 5, but you can't configure backbone area to stub area. You cannot configure backbone area to stub area. Fine. Second point, you can't configure stub area on virtual link. So virtual link are not allowed in virtual link are not allowed in stub area. Like in stub area backbone router are not allowed, in the same way virtual link are not allowed in stub area, and ASBR is not allowed in this area. ASBR is not allowed in stub area. Fine. So here in this topology you can see, if I will make area 3 is area 3 to stub area, so ASBR router is not allowed, but router 10 is ASBR, right? So we will discuss what will happen here, which type of area we need to configure here, right? This is all about stub area. So stub area is used to filter LSA 4 and LSA 5. That is important thing that you need to keep in mind, right? That stub area is used to filter LSA 4 and LSA 5. And third type of area is totally stub area. Totally stub area, and there is no any difference between stub area and totally stub area, except that totally stub area is used to filter LSA 3, LSA 4 and LSA 5. It is used to filter LSA 3, LSA 4 and LSA 5, right? Stub area is used to filter LSA 4 and 5, and totally stub area is used to filter LSA 3, LSA 4 and LSA 5 to reduce the database of router as much as possible, right? To filter LSA 3 also. Okay, so totally stub area will reduce the database of router more than stub area, right? Stub area will also reduce the database by filtering LSA 4 and LSA 5, but totally stub area will filter LSA 3 also, LSA 4, LSA 5 and LSA 3. So it will reduce the data size of database more than stub area. Okay, and apart from this point, there is no any difference between stub area and totally stub area. In the same way, in totally stub area, ASBR router are not allowed, virtual link are not allowed, and backbone area are not allowed, right? So what will happen if there is ASBR in my area where I want to reduce the size of database? For that scenario, we have 4 types of LSA, that is known as NSSA area. That is known as NSSA area. So NSSA area is used to filter, it is used to filter again LSA 4 and LSA 5, but ASBR is allowed in this area, but ASBR is allowed in this area. And fifth type of area is totally NSSA area. And totally NSSA area is used to filter. It is used to filter LSA 3, LSA 4 and LSA 5, right? And again ASBR is allowed in totally stub, totally NSSA area. NSSA stand for not so stubby area. Okay, so area concept is used to filter the database, the filter LSA, to reduce the size of database. So if interviewer will ask you why we come up with area concept in OSPF, so your answer should be like this: we come up with OSPF area concept to reduce the size of database of router, of OSPF router. Okay, so this is all about theory part, guys. Now let me discuss practically. So here, come here in this topology, let me turn on the device. And here you can see I am running some prefixes on router 1, that is 10.1.1.10.1.1.0/24 to 10.1.5.0/24 on router 1. I am running 60.1.1.0/24 to 60.1.5.0/24. This is 24. Okay, and here on router 11 I am running some network from 11.1.1.0/24 to 11.1.5.0/24. so router number 2 and router number 10 will generate LSA 5. So router 9 will receive these prefixes in the form of LSA 5 by router number 10, because router number 10 is ASBR, and router 9 will receive these prefixes in the form of LSA 5 by router number 2. Router number 2 will generate LSA 5 to share these prefixes. Fine. So let me show you the database of router 9. First of all, I have already configured OSPF here. You can verify. So IP protocol. So I am running OSPF process ID 1 here, right? And I have network advertised 0.0.0 255.255.255 and in area 3. So all active interface are present in which area? In area 3. So IP OSPF interface brief. You can see all interface are present in area 3. So IP OSPF neighbor. So there are only two neighbor, 4.4.4 and 10.10.10. Why not 5.5.5? 5.5.5 should also neighbor of router 9. Let me check configuration. So run section router OSPF. Guys, this is troubleshooting. Why 5.5.5 is not neighbor? So configuration, OSPF configuration on router 9 is fine, there is no problem. Let me check configuration on router 5. OSPF configuration on router 5. So run section router OSPF. Okay, so I have run area 3 is NSSA on router 5. So let me remove this command, router OSPF process ID 1, and say no, area 3 is NSSA. Fine. So okay, now you can see neighborship is up, state is full. Now let me show you database of router 9. So IP OSPF database. So see, now router 9 is receiving, router 9 have some LSA 1 of area 3, and this is LSA 3 who is generating router 4 and router 5. ABR router is generating LSA 3. These are LSA 3 to share the prefixes of inter area, right? So you can see this is loopback of router 1 till here, right? This is loopback which is running on router 1, and these are the network which is present in area 0. 2L network is, I am running 2L network between router 1 and router 2 here. Here I am running 12 network, here I am running 13 network, here I am running 14 network, here I am running 15 network. So router 9 is receiving all prefixes of area 0 in the form of LSA 3. But router 9 is not receiving these prefixes in the form of LSA 5. So you have to perform redistribution on edge router. So this is my edge router, router 2 and router 10. So here I will perform redistribution so that this router will generate LSA 5 to share external prefixes in OSPF domain. But now you can check that who is ABR. So IP OSPF border router. So you can see router 4 is ABR and router 5 is ABR. Fine, router 4 and router 5 is ABR. Okay, now let me perform redistribution. So go to router number 2 first. After that, here config T router OSPF process ID 1 and redistribute EIGRP 100 and keyword is subnet. Fine. Now let me advertise OSPF prefixes in EIGRP. So router EIGRP 100 and redistribute OSPF 1 and metric is suppose metric component 11111. Fine. Now here on router 9 you can check the database. You can check the database of router 9 now. So IP OSPF database. So see, this is LSA 4. This is LSA 4 who is generating ABR, right? To share the information of ESBR. To share the information of ESBR, we had discussed this thing in LSA. Okay, and here you can see this is LSA 5, external LSA, who is generating 2.2.2.2 to share external prefixes. These are external prefixes. These are external prefixes, right? So this is LSA 5. Let me perform redistribution on router number 10 also, so that this router will also generate LSA 5 to share external prefixes of EIGRP 200. So go to config T and let me verify how many routing protocol I am running here. So IP protocol. So here you can see I am running OSPF process ID 1 and EIGRP 200. Okay. So I am running both routing protocol. Let me perform redistribution. Router OSPF 1 redistribute EIGRP 200 and keyword is subnet. Fine. In the same way, let me advertise OSPF prefixes in EIGRP. So router EIGRP 200 redistribute OSPF process ID is 1 and metric 11111. Fine. Now on router 10, so IP OSPF database. This is database of router 10. So see, these are LSA 3 who is generating router 4 and router 5. Fine. This is LSA 4 who is generating again router 4 and router 5 ABR, and this is LSA 5 who is generating these LSA who is generating router 10, right? And these LSA, these external LSA who is generating router 2. Okay, now in the same way, in the database of router 9 there will be LSA 5 of router 10 also and LSA 5 of router 6 also. Sorry, router 2 also. Router 2 is ASBR, so router 2 will generate LSA 5. So now you can verify here on router 9 you can run. So IP OSPF database. So see the size of database, guys. Now okay, so in the database of router 9 there are some LSA 5 by router 10, and there are some LSA 5 by router 2. Now if you want to reduce the size of this database of router 9, what you can do, first of all I will configure stub area. What I will configure this area to stub area. I will configure this area to stub area. How you will configure stub area? So go to router number 4, router number 5, router number 9, and router number 10. So these 4 router are member of area 3. So here you have to tell to this router that area 3 is what? Stub area. So go to router 4 first and say router OSPF process ID 1, and area 3 is stub area. Fine. In the same way I have to tell to router 5 also that area 3 is stub. So go to router OSPF process ID 1 and area 3 is stub. Okay. In the same way I have to tell to router 9 also config t router OSPF process ID 1 and area 3 is what? Area 3 is stub. In the same way go to router number 10 and tell to router 10 also that your area 3 is stub. Router OSPF process ID 1 and area 3 is stub. Okay, area 3 is stub. Here you can see router is currently an ASBR while having only one area, which is stub area. And as you know, ASBR is not allowed in stub area, right? ASBR is not allowed in stub area. So IP OSPF neighbor. So neighbor is 9.9.9. State is full, right? But this router ASBR will generate what? LSA 5. ASBR router will generate what? ASBR router will generate LSA 5 to share these prefixes in this area. But this is a stub area. In a stub area, LSA 5 is not permitted. LSA 5 are not allowed, right? So LSA 5 is filtered in stub area. So this router is not able to share these prefixes, right? But guys, what will happen here? See, this router will generate what? LSA 5. LSA 5, and router 2 will share to router 1, and router 1 will share to router 4 and router 5. Now router 4 have LSA 5, router 5 have LSA 5. Now ABR router will generate what? ABR router will generate default route in the form of LSA 3, right? ABR router will generate default route in the form of LSA 3, and ABR router will forward that default route in stub area. Now you can check the database of router 9. It will make you clear. See, so IP OSPF database. See, is there any LSA 4 or LSA 5? No, LSA 4 and LSA 5 is filtered. But here you can see 4.4.4 and 5.5.5 is generating a default route in the form of which LSA? In the form of LSA 3. So in stub area, ABR router will generate default route in the form of LSA 3, and now I can ping 60.1.1.1. See, I am able to ping, right? So size of database is reduced because ABR router is generating default route in the form of LSA 3, and ABR router have information of 60 prefix, right? ABR router have information of 60 prefix. You can verify on router number 4 or router number 5. So IP OSPF database. In their database, you can see there is LSA 5 of which router? Of router 2, but there is no LSA 5 of router 10, right? Because router 10 are not allowed to generate LSA 5 in stub area, because LSA 5 is not allowed in stub area. So only ABR can generate LSA 3. ABR can generate a default route in the form of LSA 3, and ABR router will share that default route in stub area. Okay, so here you can see in the database of router 9 there is 2 default route. Who is generating? ABR router. But now can router 9 ping to this prefix? No, this router cannot ping to this prefix, right? So here in my network there is one ASBR, so we will configure this area as area to NSSA area, not stub area. But before discussing NSSA area, let me discuss totally stub area, right? So now guys, size of database is reduced, but still the size of database is large. There are lot of LSA 3, and suppose in area 0 there are 2000 prefix, so again size of database of router 9 will be very large, right? So if you want to filter LSA 3 also, what you can do, you can configure this area to totally stub area. Now if you will check routing table of router 9, so IP route OSPF, there will be 2 default route, right? There will be 2 default route towards router 4 and router 5, and router 4 and router 5 have prefix to reach in 60 network. But no problem is these router 9, router 4, router 5, router 1, router 2, router 3, any router cannot communicate with 11 network, with 11.1.1.0's network, because ASBR is not allowed in stub area. Okay, so hope it's clear to you. Now let me discuss totally stub area. I want to filter LSA 3 as well of router 9. In the database of router 9 there are too much LSA 3, and I want to filter that LSA 3. So what we need to do, we need to configure totally stub area. So go to router number 4 and say to router OSPF process ID 1, and area 3 is stub, and to configure totally stub you have to add this keyword no summary to not generate LSA 3. LSA 3 is summary LSA, right? Enter. In the same way you have to tell to router 5 also, because ABR router is generating LSA 3 and I am forcing to ABR router to not generate LSA 3 in stub area. So go to router OSPF process ID 1 and say area 3 is stub, no summary. Okay, now if you will check database of router 9, you can see the database of router 9 now. So IP OSPF database, see guys, this is database of router 9. This is database of router 9. There is only one default route. There is only one default route. So IP OSPF neighbor is 10.10.10, 5.5.5, 4.4.4. But why there is no LSA 3, LSA 1? Let me run router OSPF process ID 1, area 3 is stub and no summary. So IP OSPF database, yes, see, this is LSA 1 and this is LSA 3. So in totally stub area, ABR router will generate a default route in the form of LSA 3, and LSA 3 is filtered now, but still I can ping 60.1.1.1, right? Or you can check routing table of this router as well. So IP route OSPF, there is only one default route, right? And next hop is router 4 and router 5, which is ABR, and ABR have these prefixes, 16 prefixes 10 prefixes, right? So I can ping 10.1.1.1 also, which is present in backbone area. But I am not able to ping the prefixes which is present in EIGRP 200 domain. See, I am not able to ping. So here what we need to configure NSSA area, because in my network there is one ASBR, and ASBR is not allowed in stub area, right? So we cannot configure stub area here. We can configure NSSA area. NSSA stands for not so stubby area, not so stubby area. Okay, so let me show you how to configure NSSA area. So first of all, go to router number 4 and let me remove this command. No, say no area 3 is stub. Go to router number 5 and let me configure area 3 NSSA. Okay, in the same way, go to router number 5 and say let me remove this command first. No area 3 is stub, right? And area 3 is no NSSA area. Okay, in the same way, go to router number 9 also. So you have to configure NSSA area on every router which is part of area 3, right? So router OSPF process ID 1 and say no area 3 is stub first, no area 3 is stub, no summary, right? And area 3 is NSSA. Fine. Now go to router number 10, config T, router OSPF process ID 1, no area 3 is stub. Fine. Now guys, area 3 is what? NSSA, right? Now you can check database of router 9. Now what will happen? First of all, understand. Now ASBR router will generate LSA 7, to share external prefixes in NSSA area. What is the use of LSA 7? LSA 7 will be generated by ASBR router to share external prefixes in NSSA area. Earlier ASBR was generating LSA 5, but in NSSA area LSA 4 and LSA 5 are not allowed. So that's why ASBR router will generate LSA 7 to share external prefixes in NSSA area of OSPF domain. Okay, now you can verify it. Go to router number 9 and run so IP-OSPF database. So IP-OSPF database. Now you can see this is LSA 3, right? Is there any LSA 4? No. Is there any LSA 5? No. But there is LSA 7. Who is generating 10.10.10.10? Who is generating 10.10.10? Means router 10 ASBR. So router 10 is part of NSSA area. That's why this router is generating LSA 7. So ASBR router which is connected in NSSA area will generate LSA 7. But how router 9 will receive these prefixes now? How this router will receive these prefixes? Because my ASBR is router 2. This is my ASBR. So this router will generate, this router is generating LSA 5. And that LSA 5 will receive by router 1. Router 1 will forward to router 4 and router 5. Now this router is not ASBR. So this router will not generate LSA 7. So you have to run one more command on ABR router, to make ABR to ASBR. With the help of one more command, you can make ABR to ASBR. Now once I will run that command, these two router will start acting as ASBR. Once these two router will start acting as ASBR, these two router will generate what? LSA7. This ABR router will generate default route in the form of LSA7, because ABR router means router 4 and router 5 have this prefix. If these two router will generate default route, so router 9 can reach to this network. Yes or no? Yes. So we will run one command on ABR router to make ABR router to ASBR router. What is that command? Command is, guys, this one. Now you can see on router 9 there is only 11 prefix. There is no 16 prefix and there is no default route. There is no any default route, right? So router 9 cannot communicate with 60.1.1.1. Yes or no? Because there is no prefix and there is no default route. So go to router number 4. Okay, go to router number 4 and let me show you. So IP OSPF border router. So border router, if you will run this command, you can see 10.10.10 is ASBR, right? 2.2.2 is also ASBR, and 5.5.5 is what? 5.5.5 is ABR as well as ASBR. So I have already run this command, I think, right? Router, let me check. So IP protocol output of this command. So yes, this is an area border router and autonomous system border router. So let me remove this command. Router OSPF 1 no area 3 is NSSA default information originate, this command, right? So IP protocol. So now still this is autonomous system border router. So this is problem of GNS3, right? So after running this command, actually once you will run this command on ABR router, router OSPF 1 and area 3 NSSA default information originate. This is command to make ABR router as ASBR. After running this command, ASBR router will start generating what? LSA 7. So you can verify on router 9. Now still I am not able to ping 60 network. Just wait, guys. So IP OSPF database LSA 7. So IP OSPF neighbor is fine. Let me check database of router 4. Okay, so first of all let me run this command here, right? Now this router will generate LSA 7, I think. Let me check. So IP OSPF database, where is LSA 7? Now here you can see, now router 4 is generating a default route in the form of LSA 7, right? In the form of LSA 7. So on router 4 you can check. So IP protocol, this is ABR as well as ASBR. So after running default information originate command, this router will become ASBR, right? But earlier, now you can verify on router 5. Router 5 is also saying that I am ASBR, but this is error. So IP protocol. So IP protocol. So this router is also saying that I am autonomous system border router ASBR, but this router is not generating LSA 7. So IP OSPF database, right? So in real time see, only router 4 is generating LSA 5, right? Sorry, LSA 7, and there is LSA 5 also. So you have to run one command on router 5 so that router 5 will also start generating LSA default route in the form of LSA 7. So go to router OSPF process ID 1 and area 3 NSSA default information originate. After running this command, this router will become ASBR, right? So it's showing wrong output. This is problem of GNS3. On real device, you will never see that this router is ASBR before running this command. Okay, so once I will run this command, this router will also generate what? Default route in the form of LSA 7. So IPOSPF database, you can see LSA 7, right? So now both router is generating default route. Now router 9 will receive default route in the form of LSA 7 by router 4 and router 5. So IPOSPF database. Now you can see router 9 is receiving 2 number of LSA 7 by ABR router, but now ABR 4.4.4 and 5.5.5 is ABR as well as ASBR. So IPOSPF border router. Now you can see 4.4.4 is ABR as well as ASBR, 5.5.5 is ABR as well as ASBR, and 10.10.10 is only ASBR. So in NSSA area, ABR router will generate LSA 7 to share the external prefixes of ASBR which is not connected in that area, which is not connected in that NSSA area, like this ASBR. This ASBR router is not connected with NSSA area. This is NSSA area. So this router will, ASBR router will generate LSA 5. This LSA 5 will be received by ABR, and ABR will generate LSA 7. The ABR will generate default route in the form of LSA 7. If you will run default route information originate command, then only, right? So default information originate command is used to make ABR to act as ASBR, Fine guys. So this is all about NSSA area. But here you can see in the database of router 9 there are too much LSA 3. So IPOSPF database, there are too much LSA 3. So suppose there are 1000 or 2000 prefixes in area 0. So ABR router will generate 4000 because there are 2 ABR. So each ABR router will generate 2000 LSA 3. So if you want to filter LSA 3 as well, what you can do, you can configure area 3 as totally NSSA area. So command will be same like totally stub area. Go to router number 4 and say router OSPF process ID 1 area 3 is NSSA and no summary. Fine. In the same way, let me copy this command, let me paste the same command on router 5 also. Config T router OSPF process ID 1, and let me paste this command here, right? Now go to router number 9 and you can verify database. So IPOSPF database. So let me clear IPOSPF process, say yes, and now you can verify. So IPOSPF database. So still there is LSA 3. Go to config T router OSPF 1 area 3 NSSA and no summary. So IPOSPF database. clear IP OSPF process, say yes. Okay, so router 5 is generating LSA 3. So let me check configuration of router 5 again. Let me run area 3 NSSA and no summary. Clear IP OSPF process, say yes. So IP OSPF database. Now you can see the size of database is reduced, right? There is no LSA 3. Now ABR router will generate default route in the form of LSA 3 in NSSA area, in totally NSSA area, right? So totally NSSA area is used to filter LSA 3, LSA 4 and LSA 5. There is no LSA 2, no LSA 3, no LSA 4, right? So still I am able to ping 60.1.1.1 or not. So see guys, yes, I am able to ping, right? Am I able to ping 10.1.1.1 or not, which is present in backbone area? Yes, I am able to ping. Am I able to ping 11.1.1.1 or not, which is present in EIGRP 200? Yes, I am able to ping, right? So this is area concept. Okay, now my question is how router 1 will receive these prefixes, right? Now this is ABR as well as ASBR. This is also ABR as well as ASBR, right? So router 10 is generating LSA 7 to share external prefixes in NSSA area of OSPF domain, right? Router 9 will receive this LSA 7, router 9 will forward to router 4 and router 5. Now one router out of these two ABR, suppose this is ABR 1 and this is ABR 2. So one ABR will relay this LSA 7 to backbone area, to inter area, to router 1. So router 1 will receive these external prefixes by router 5 only, not by router 4. So router who will have highest router ID will generate what? Will generate LSA 7. So see here on router node, this is router 10, router 1. So IP OSPF database. So see 11 prefixes. So who is generating LSA 5? Right? There are two ABR, sorry, two ASBR. Now these router are ASBR also, ASBR, right? And ASBR router will generate LSA 5 to share these prefixes. So which router who have highest router ID will generate LSA 5. LSA 5 to share external prefixes in OSPF domain. So these are ASBR. So these router will generate what? LSA 5 to share external prefixes. External prefixes means these prefixes in OSPF domain, in OSPF area 0. But these router are receiving information of this network in the form of LSA 7, right? But router who have highest router ID will generate LSA 5 to share the external prefixes, which is present in the database of router 5 and router 4 in the form of LSA 7. You can verify it. Go to router number 5 and see guys. So IP OSPF database LSA 7. See 11.1.1.0 to 11.1.1.5.0 and receiving via which router? Router 10, right? So these are external prefixes. So this is ASBR. This router will generate what? LSA 5 and it will share with router 1. Now you can verify the database of router 1 and see there are LSA 5 because LSA 5 are allowed in backbone area. This is a standard area. By default all area are a standard area, right? So here you can see these are prefix. Who is advertising this prefix? Who is advertising this LSA? Router 5. But is router 5 is actual forwarder? No, actual forwarder is who? Which router is advertising these prefixes? Actual advertiser is router number 10. Am I right? Router number 10 is actual advertiser. So how router 1 will came to know about actual advertiser? It will open their database in detail. External. So IP OSPF database external 11.1.1.0. 11.1.1.0, and see guys, here forwarder address is 109.0.0.10. So with the help of this command, this router will came to know about the actual forwarder. That router 4 or router 5 is not actual forwarder. Actual forwarder is router number 10. This is IP address of router number 10. And who is advertising? 5.5.5. But 5.5.5 is not actual advertiser. So IP OSPF root. So IP root OSPF. See 11.1.1. Reachable via router number 4 also, and reachable via router number 5 also, and reachable via router number 4 also. This network also, this network also, this network also, this network. Okay. So if you have watched my LSA video, right, that I have posted in day 1, right, then it's very clear to you, right? Type area concept in OSPF. Okay, and that's all for today. If you have any doubt, please let me know in comment. Definitely I will make one more video on OSPF area concept. I don't have any problem to make multiple video on same topic, but if you have any doubt, please let me know in comment. But if you don't have any doubt, if it's clear to you, if you have learned something from this video, please don't forget to like this video. Please don't forget to subscribe this channel. That's all for today. We will meet soon in next video. Till then, stay safe guys. Bye bye. That's all for today.